Good evening once again. This side Tasneem, the Senior Manager at Vijesha IT Services LLP. It gives me an immense pleasure to welcome all of you to this international exclusive Techno Live web. Seeing such an enthusiastic and diverse audience today truly excites us. Before we begin, I kindly request all the participants to turn on your cameras so that we can capture some wonderful moments together. Please note that the session is being recorded and will be shared with your respective colleges. And we also warmly invite college authorities and faculty members to join us. Students, feel free to request your lecturers to be a part of this session. So let's maintain a professional, interactive, and energetic environment throughout today's webinar. So many of you might be wondering who we are and what's special today. So we are Vijesha IT Services LLP, a leading software edtech platform and a digital marketing platform proudly recognized as the North Karnataka's first edtech platform. We operate through physical branches in Hubli and Karnataka, Bangalore, along with a virtual office in UK, England. We are a UK government certified company, MSME Indian registration approved company, Startup India recognized and officially registered on the video portal. Our mission is yet simple but powerful to build future ready IT professionals through hands on training, live project exposure, industry aligned curriculum, and global learning standard, focusing on the most in demand and rapidly evolving technologies. Also, stay connected with us for the latest tech insight, career opportunities, internships, and skill based programs. Make sure you follow us on all our social media platforms, especially LinkedIn, Instagram, and YouTube. And also, we are excited to announce a new campaign and initiative taken by our company designed with one clear goal to help students gain real industry exposure and practical learning. So, this initiative officially begins from today and will run till April. So during this period, we'll be conducting almost 9 exclusive industry-focused webinars, each aimed at bridging the gap between academics and the real-world technology. So how the selection works is from each webinar, we'll be shortlisting almost all any one of the participants. So right now I can see there are almost 260 participants into this webinar. So hoping almost everyone to be our one of the followers. So any one of the winner will get a golden opportunity for a real industry exposure, a chance to work closely with our team or to gain hands-on experience. And also the winner will be featured on our social media platforms. It might be via LinkedIn, Instagram, or YouTube, giving them visibility and recognition. So all the social media links has been dropped in the chat box. So I request the team to drop in the links. So students, what you have to do is just click on the links and go on to the social media platforms. It might be Instagram, LinkedIn, and YouTube. So go over there, follow us, and make sure that you are grabbing in this amazing opportunity. So I'll give you all another 2 minutes to do it. So hurry up and grab this in. So students, I hope you all are doing it. So don't miss this amazing opportunity. So can you guys raise in your hand like who all have already followed us on our social media platforms and also subscribed us on YouTube? Only 10. I guess very few students wants to grab in this opportunity. Rest of them not interested. It can be anyone among these 267 participants who can be that one lucky winner. Hurry up, students, the time is running out. Only 35 people. 44, 45, it's increasing. So happy to see such enthusiastic crowd today. I'll be giving you up another 2 minutes. This campaign will only run when we are having almost all 200 followers on our particular social media platforms. So there are 60 of them. Another 140 people to go in. It's very simple. Just you already have in your phones at your hand, right? So you can just grab in this opportunity. If you have followed, you can just raise in your hand. Seventy-two. Good. 81 people. That's good. Okay, so make sure that you guys are following us, stay active and attend the session because this campaign would be your entry point into the industry. And the winners will be announced and officially tagged on our social media pages. So stay connected, keep an eye out, follow, learn, and get industry ready. Also, don't miss this opportunity. Your follow would turn into your future. Yes, this webinar would be the gateway to your next live project experience. And also all the details related to the certifications, including the process and the official links will be shared at the end of the webinar. So I strongly request you to stay connected till the very end. And also to make things even more exciting, we'll be even hosting a quiz challenge, a special challenge at today's end of the session. And what rewards you here is you will be getting a very free opportunity to work on a live and a real project. That is basically you will be getting an opportunity to work as an intern with us. And also you'll be getting a direct mentorship under today's speaker and also a certificate. And also the other top performers will unlock some exciting opportunities and rewards. So stay focused, participate actively, and give it your best till the very end. So data analytics is not just a training domain, it's the future. From finance to healthcare, sports to e-commerce, data is driving decisions everywhere. As the world becomes more data-driven, skills in data analysis, visualizations, and interpretation will be among the most demanded in every industry. In today's session, you won't just be listening to a lecture, you'll be getting a direct insights from someone who is working at the forefront in the industry. We are honored to have with us Mr. Ashraf Mulla, a brilliant mind in the field of data analytics. He holds a B in mechanical engineering and a master's in automotive mechatronics from Cranfield University, UK. one of the top most institutes in the world. His journey includes experience as a system engineer at Alten Limited UK, CA engineer at Altair Business Solutions India, and currently he is working as a data analyst engineer at Jaguar Land Rover UK. So gear up into the divine world of data. Understand how industries leverage analytics, and most importantly, discover how you can shape your future in this exciting domain. So, without any further ado, let's welcome the man of the hour, Mr. Ashraf Mulla. So are you there?
Yes. Hi, Tasneem.
Okay, over to you.
I hope you can hear me properly.
Yeah, you're audible to us.
Okay, lovely. Just give me a moment. I'm just setting up my screen so that everybody can view me. Just a moment, everyone. Okay. Give me a moment. I'm just checking if you can see my screen now. Mhm. Okay. Okay, cool. Perfect. So let me share my screen and my face as well. Cool. Okay. All right. Can you please confirm if you can see my screen and also my face? Just a bit of housekeeping. Yep. You can see the screen.
Yes, Ashraf, the screen is visible.
Great. Okay. Thank you very much. So, hello, everyone. Good evening. Uh, Thank you for being here. Thank you for showing interest around the hot topic of data analytics, what that is, and a bit more about how the industries are using data and what does data analysis help them. This webinar is going to be a bit more interactive. I'm going to give you very fundamental things give information about very fundamental things and fundamental questions, basic questions that anybody could have. Let me remind you that this session is going to be in English completely. If you have any questions in regional language that you want to answer, please give a shout out to any of the Vijesha team members. They'll be able to help you out in answering any of your questions as well. And yeah, at the end of this session, you will be having a quiz, which I highly encourage everyone to take part in. So the winners of that quiz will be getting access to a live project and also an internship to work with Vijesh as well. So stay tuned. I highly encourage you guys to focus on the webinar as well and ask as many questions that you have. And yeah, don't think that there is any wrong question, bad question, or nobody's going to judge you, because the things that you might be knowing and the things you might not be knowing is something not so common across the whole cohort. So we got about 280 people in this webinar right now. Not everybody will be knowing the same thing, so don't hesitate at all. I highly suggest you guys to please ask questions as much as you want. And I hope you can take something better out of this webinar. So as the time that you're spending here, it'll be worthwhile for you. And yeah, let's crack on with data analytics. Now, firstly, a bit about me. Yeah, so who am I? Why am I here to speak in front of you? Everything. So yeah, I'm Ashraf Mulla, and I've completed my bachelor's in mechanical engineering from KLIT Hubli back in 2019. Then I worked as a CA engineer down in India, in Bangalore itself, and then COVID hit, and I started to pursue my master's in automotive mechatronics. So automotive mechatronics is something that I was keen on taking up because that was my passion, that was my interest. And I did some really interesting projects with Aston Martin, designing the electrical anti-roll control system for DBX 707. Worked on some highly intuitive projects alongside with the university as well. So post doing my MSc, pursuing my MSc and completing it in 2022, I jumped on to being a consulting engineer with Alten, and I was working with JLR at that time as a consulting EDU engineer. So EDU is electric drive unit in an automotive system, where I was tasked with making sure the delivery happens on time, following all the gateways in automotive industry. And after that, after a quite short stint in JLR, I moved to Aston Martin. Aston Martin is where a bit of more intensive work that I took place, more towards engineering, mechatronics, vehicle dynamics, as well as some of data analysis that I did there, which was track assisting data analysis. So there is data analysis in track as well. That's where I'm going to come and explain exactly how does a mechanical engineer and automotive engineer move into the domain of data analytics. Scope around that. I'll be speaking about that as well, so that some of the people who might not be aware of how the industry navigates and what's the usable, what's the advantage of having data to any industry is currently there. The possibilities and power of all of the data as well. I'm going to tell about that. So yeah, after that, working with Aston Martin Vehicle Dynamics for about 6 months on a certain project, I moved on a permanent position to JLR as a data analyst. So working as a data analytics engineer, my key role was to analyze the engineering data using all the systematic tools and systematic information and systematic operating tools that we've got to interpret and translate that data knowledge and data engineering understanding into much more intuitive and human understandable high level language information. So that's where my whole journey began, and everything that started working on as well. So now currently I'm the product owner of data analytics in a current quality management team. So I'm really focused on improving the quality of the Jaguar Land Rover cars, everything, including Defender, Range Rover, Range Rover Sport, Evoque, Discovery, everything. So we've been using data from selective customer cars as well as the fleet engineering cars to make sure the products are developed in a much more robust and effective manner by using all the insights that we can find in data, and provide that to product development and also to the organization as well to make informed decisions. So that's what I'm doing. I'm translating the engineering data and making sure the people who are actually using the data, they are very well defined and informed about what is actually happening with the products and how are the customers using our cars, what are the problems that they're facing through, and what is the diagnostics issue around that. So it's a big thing. It's not just very simple when I speak about data analysis. So you might now get a bit of gist around how data analysis is intertwined across in in various industries. Now that's about me right now, and we are into vehicle platform department, so which is a big department as focus on everything from a car, the propulsion systems, body and chassis systems. So focus on everything, analyzing all of the data to make sure the product development happens appropriately according to the gateways that they are set. Okay, cool. Moving on to the today's webinar. So what we're going to speak about today, firstly, it's all about data analytics. What types of data analytics, tools and technologies, industry impact, and also I'll speak about what is the current market, how is the current market, and how much value will you be having if you pursue a career in data analysis, in what industries, and I'll also take some questions, very healthy questions from everyone as well. I'd highly encourage to ask questions, you all to ask questions, because if you don't ask these questions now, if you don't ask these questions to a person who's actually working in industry, in a very dynamic industry, in a very interconnected industry, you won't be getting these answers anywhere else. So yeah, let's crack on with that and move on to the first topic, that's all about data analytics. Before I begin with explaining data analytics, I want to throw a question at everyone, and I want very genuine answers from everyone. I'd highly appreciate if you can turn on your mic and answer. But please, if you can't do that, send us a chat as well, just explaining what you think about what. My question is, what do you think is the difference between a data scientist and a data analyst? What is the difference? What is data analysis and what is data science? What is the difference? I'll give you 2 minutes to give you an answer. If anybody wants to speak up, you can show your hand. So I can see some hands there. I can see a hand from Tasmia, from Praveen, and Prajwal. I'm not sure if you're able to, if you're here to answer that. If anybody doesn't want to speak up and answer, please go ahead and uh, drop in a chat. Drop in an answer is a chat as well. That's fine. So, anybody want to go first? Tasmia, do you have an answer for this? Okay, no, looks like Sairaj has a background in the in his mic, which he is not able to mute off. That's okay. So, is there anybody who wants to answer this?
Sure, ಹೇಳಿ.
A data scientist and a data analyst.
So may I answer?
Is it Nikhil?
Yes, sir.
Yeah, go on,
No,
Nikhil.
Ishwar want to tell. Ishwar want to tell.
So the major difference between data analytics and data scientist is data analytics deals with previous data and analyze it, whereas data scientist deals with future data. He predicts the data and he try to understand the data.
Yeah, great. Thank you for your effort in answering. Although you are 50% right, 50% still you're a bit deviated. So I'll help you to understand a bit. Thank you for that very much, Nikhil. Yeah. Anybody else? Come on, this is your time for you to show off. You might be having your faculty members as well. They'll be watching you guys. I got some question over chat as well. Let me read the chats as well. So I really hope that you guys are not pasting anything from Chat GPT or any of the GPT models, Google Gemini, and everything. Don't do that, please, because you will be cheating on yourself. The first question from Meghana, first answer from Meghana: data analysis is equal to understanding data. Data science is equal to understanding plus predicting using data science, using data. 60%. Still 30% a bit misleading, misguiding, I believe. But yeah, thank you for that, Meghana. Savitri, data analyst explains the past, data scientist predicts the future. Yeah, this is the very big misconception that you all have, that data scientist only does something for the future, which is not correct. I'll explain that to you. But yeah, thank you, Savitri, for your answer, for your effort. As is, data science uses algorithms, statistics, and machine learning to predict future trends from data. Data analytics examines existing data to understand past and present results. Meghna also tells the same thing. Then again, okay, reporting past. Prashant says that they are cheating here. Okay, yeah, all right. Someone's blowing the whistle. Then it's okay. I've got many answers there, but don't worry. I'll spill the beans for you. I'll give an answer. Very distinctive answer about exactly what the difference between a data analyst and a data science is. See, data analysts don't just work on present data. The analyst works is not just to work on data on present data. There are different types of data analysis as well. So specific type of data analysis requires us to perform certain analysis and give out certain outcomes out of the analysis. And a data scientist, what a data scientist do? Data scientist, what does a scientist do? Take that role down itself. Data and scientist. What does a scientist do? Scientist goes on the basic principles. It's called as first principles in science. Now, first principles everywhere. First principles are in physics. First principles are in chemistry, are in data, in biology, in zoology, everywhere. First principles are everywhere, including arts has first principles as well. Now, scientists builds on first principles. They use the basic principles. For example, if I just need to give you a basic fundamental example, the Fourier transformation, the Fourier series that you have, that's one of the basic principles. And then in physics, that you have Newton's law. So these are basic first principles. Now you develop on this one. You try to do experimentations. You try to create something out of this. You try to invent something out of this. So data scientists, they create something out of this. They have the whole world for themselves. They use data as their building blocks. They use data as their method, as their way to build something. It could be a data model. It could be a model that showcases anything about the past, anything about the future, anything about the present, or trying to simulate something as well. So data scientists and architects also work on they try to visualize or create a virtual model of the real world. That's the difference between data scientist and a data analyst. Data analyst analyze the data. Data scientist create something from data. That is a key difference. There's a key difference. Now, Data analysts do create something out of that, but they are more over conveying a message rather than creating something. So that's the key difference in a data analyst and data scientist. Now, for your answers where you've got where you told me that data analyst just focuses on the past data and data scientist predict the future. No, you're kind of wrong. Yeah, let me repeat once again, Megan. So a data analyst analyzes the data, whereas data scientists build something out of the data. Now, there is a key difference in both of these people as well. The data that they use. There is a different type of data as well. Okay, it's quite in detail, but I'll try to give you a brief about what that means. Now, you might be knowing that you have raw data and you have processed data. So raw data is always unprocessed data. So you have raw data and you have processed data. In order to work as an analyst, an analyst will always rely on processed data. The reason why they do that is data in itself, in its nature, it's non-linear because data is replicating the real world. Real world is non-linear. Now, what do I mean by linearity and non-linearity? See, in world, a world or the real world is actually non-linear. The reason why we tell that is when we break it down to science, when we try to relate it to science, we have specific formulas. We have specific formula. F is equal to ma, force is equal to mass into acceleration, Newton's momentum law. You have these fundamental laws. Now you expect that the nature should behave exactly like this, but it doesn't happen. We have thermodynamics laws as well. Thermodynamics, zeroth law, first law, second law, third law. Heat input it should be equal to heat output. That should be a very it should be equilibrium law, but it doesn't happen because you have losses in between again. Now the formula does give you a linearity example. That means LHS is equal to RSS. That exactly should be how the world should behave, but that doesn't happen. You will be having constants in between them. So A is not equal to B. A is equal to KB. So K is always a constant. That K is a constant, is a coefficient of non-linearity in the world. Now this non-linearity, when you're trying to get everything from the real world and convert that into data as well, this non-linearity will get into that data. So that means that the data will also have non-linearity and data will have its issues. Data will have quality issues. Data will have reliability issues. Data will have lots of problems which require some pre-processing before you use that. So analysts use this data. Analysts use this pre-processed data, process data. They use the pre-processed data because analysts can't spend their time to do much of the very critical job of cleansing and processing and structuring the data. Whereas data scientists rely on raw data. The reason why they rely on raw data is raw data gives them everything. Raw data gives them all the non-linearities. Raw data gives them issues. It shows them what issues are, what are the outliers are. I mean, outliers is something that how much your data is deviating. That means if you want to draw a picture, you'll use proper colors. When back in school, if you remember in LKGs and UKGs, you were given a palette of colors. You had 12 colors to paint a picture. Okay, you use that to paint a picture. Now, what the image that you get is exactly distinct to only those colors. You can't mix and match. You can't create very definitive colors. Whereas if you see artists like Leonardo da Vinci, Da Vinci also painted. Okay, there are various painters as well. So many other painters, what they do, they don't restrict themselves to a palette of color. They use colors, they mix it thoroughly by their own knowledge and create something. Now that gives a very distinct finish, that gives a very distinct color. That color you won't find in a palette. That is a very clear example how and what an analyst and a scientist does. Analyst uses a palette of color where everything is structured and he can get some answers out of that. Whereas scientists, they use raw data. They use raw format of data so that they can create a much more real and a realistic replica of what the real world is trying to showcase. So that is the clear distinction. That is the difference in how the world is defined around data analyst and data science. So it's much more about data rather than what operations are done. So an analyst focus on something and data scientists focus on something. So what I'll do right now is I'll take you through how data analysis is done, what is the day-to-day jobs of data analyst, and at the end I'll explain you how does it different from data scientist. What does a data scientist do in difference to this? Okay. Cool. Moving on. I'll take the questions later on. If you have any questions, if there is a question that you're very excited to ask about, you can go ahead and ask. That's not a problem. Or else you can put that question in the chat box as well. We'll read through the questions later on as well. But please don't spam the chat box. It will show your own values and your own behavioral ethics. Because if you keep chatting, if you keep spamming your chat box, that means you're not showing a good reputation around your own institution, about your own self. Don't do that, please. Give equal chance to everyone who's there on chat. Everyone is here to listen to what's being conveyed. So let's just please maintain the decorum as well. Okay. Cool. Now, methodology. This is the methodology of a data analyst. Now you have this step here. You have raw data, you identify, you collect, clean, analyze, interpret. Now I told something that data analysts don't use raw data. I told that data analysts don't use raw data. I told that data analysts use processed data. Now this is where the caveat is. A data scientist is also a data analyst. So if I need to give you a clear distinction of how this is, first comes data analyst, then comes data scientist. So a data scientist should always have the skill set of a data analyst. So I should build upon that one, because the analytical tools and analytical skill set and experience is very fundamental to be a scientist, a data scientist. Because the things that you do as an analyst is something that you carry forward to do as in the form of a data scientist. Raw data. Not every time a data analyst uses raw data. Mostly they use processed data, which is coming out of warehouses, data warehouses. Now, what are these data warehouses? Big companies like AWS, Snowflake, Google Cloud, they maintain clouds, they maintain cloud architects where they have data warehouses, where they maintain data with specific standards, governing policies, organization structures, and GDPR rules, and making sure the efficiency and effectiveness of data is maintained. So that's what cloud companies do. So data will be there usually in clouds. Now, data lake is something different, and data warehouse is something different that you can only understand when you go a bit more deeper into this. So raw data. Normally, when someone needs to create a certain type of specific model, so if someone needs to analyze certain data, they try to prefer raw data. If not, they will straight away go on to processed data. That is warehouse, enterprise data, warehouse data. So the first step, now this is the whole process, how everything starts from the birth. Okay, this is not how day's job of an analyst that I'm actually speaking about. You have raw data, and then you identify the bits and pieces that you exactly need to fetch out of that data. You collect that data, then you clean that data, and you analyze and then interpret. We have these different steps here. Now you can read the definitions here. These definitions is not stick to or bound by a specific author or specific textbook. Don't do that, because the intention is to make sure you understand what data analytics is. Okay, so data analytics is a process of analyzing raw data using various techniques and interpreting that into meaningful human understandable form. That is the job of an analyst. Don't think anything otherwise out of that. That's the basic fundamental job of an analyst. Now there are certain steps that analysts do. Identifying the data. In identifying the data, there are certain fields. If you guys are from computer science background, if you guys are from AI, ML, data science background, you might be knowing that data cannot be lying in a bag. You cannot carry data in a bag. Data always is structured and labeled in form of a table. It will be in a tabulated form. If not, it is raw data. You will need to structure that data, and that will be done by various other people like the warehouse operators and cloud operations. So that will be done by them by assigning labels and everything. But in order to make sure the analysis that you're doing, you need to identify the data. So you identify the data, what data you need to use to provide certain information, and then you make sure you sort them. You have exact labels. You do a bit more skimming through all of that data labels to figure out you're using exact same fields, the data that you need. Then you collect that data. Now see, what happens is, when you're analyzing, you might not be using same tools. You might be using various different tools. Because if you're in a company, if your company uses multiple tools, then the cloud operations that you use might not be the same platform where your analytical or the visualization tool or the software will be as well. You might have to collect them properly somewhere. Now it could be into your personal sandbox. It could be into a project in Google BigQuery. It could be a project in Snowflake. It could be a project in AWS as well. So you could have some different projects associated to your own team, to your own department, to yourself, where you collect that data to work on. You cannot work on the data that is there actually in the warehouse or the data lake itself. You cannot manipulate that, because that data should be there for others to use as well. You'll just extract that data and work on it. You will not manipulate the real root folder. That's the difference in that. So that's why you have to collect the data. There are various things in collecting data as well. Now, this is where IT rules and regulations and as well as IT restrictions come into play. Now, you have certain bandwidths of data that you are going to fetch. Cost is a very key bit here. Energy efficiency is also key bit, because you know that processing data that takes a lot of energy. Trust me when I'm telling this. If your computer is running a software, if your PC is running a game, let's say GTA 5. If your computer is running GTA 5, think of it how hot your how hot your laptop will become. Any of your PC items, any of your PC devices will just burn off. It will be very hot. So your fan will be doing, overloads of work. It will be doing overtime. Your fan will be just fetching or trying to get all the heat out of this heat sink. It'll do all the job. But imagine this. Imagine the data servers which are holding GTA 5 on the server and making sure millions of people are running GTA 5 on the server. They're continuously accessing data in milliseconds, in nanoseconds. They are not in milliseconds. They are doing that in the interactions on the iterations of 1/10 of a second, nanosecond specifically. They're doing all the calculations and transmission and interpretation, transmission, transformation, visualization, everything within that short bit of a time to millions of people. Imagine the workload of all of those servers that will be taken out. So imagine how much money they would be spending for the architecture. Imagine how much money they'd be spending to keep the systems cool, because if the systems get heated up, your laptop won't work. Think about the server systems or server rooms. What will happen to them? That's the reason certain infrastructure is set up properly to make sure those data centers are cooled up very effectively and efficiently. And you might have seen that many of the data centers are very much close to seaside, because they use seawater to cool the data centers. And in fact, some of the European countries are actually using the heat out of data centers to heat the cities. That's how much heat is generated out of the data center. So it is important to make sure that you are using proper standard operating procedures when you're handling data. Make sure that you're not costing too much energy, you're not costing overload burden to your pipelines as well. So that's something falls under collection of data. Then you have cleaning. Now, cleaning is where your actual skill set comes into play. This is where your analytical and cleaning skill set comes into play. Your knowledge of understanding how to use data comes into play. So you clean the data very efficiently by using all the tools and techniques. Then are there using the SQL scripts? You do that. And then moving on, when you're thoroughly sure that your data is cleansed, matching up to certain metrics, you move on to analyzing the data, where you use certain visualization tools like Minitab, Power BI, Tableau, or Excel as well. You can use that to analyze by creating charts, graphs, comparative charts, various types of charts to give you proper different metrics. And then you use these charts, you use these analytical interpretations to create an exact interpret. You can create communication slides, you can create certain reports, you can create certain posters and banners, and as well as create some web pages on certain apps that can be used to interpret your data. So there are companies like Statista, which are doing very, very good job in analyzing a lot of data out of the whole world. So they use YouGovs or various governmental associations survey data to show all the statistical results. So Statista is a very good company that they're doing that. You can take inspiration from that. So this is what happens in a proper methodology of a data analyst. Okay. Now, moving on. Types of data analytics. This is very key, very, very important for you to understand. The answers that you all gave me, that telling that analysts just focus on past data, not on future one. Data scientists focus on future data, not on past one. No, I'm going to correct that understanding. So please give a bit more attention to this. Now we see data analytics. There are different 4 types of data analysis. This doesn't fall straight away into data science. Okay, not straight away to data science, but this is still analyst job. There is a bit difference in this. When you get into the field, you'll understand a bit. Okay, data analyst. There are 4 specific distinct types of data analytics. First is descriptive, then comes diagnostic, then comes predictive, then comes prescriptive. Now the difficulty level and the complexity level increases from top to down. First one is descriptive. That is what is going on. Basically, the things that I've mentioned in the backend there that tells you about asking you a question. So what, why, how, well, if you know this fundamental thing of answering to a problem solution thing, I've added it there. So descriptive type of analytics or analysis tells you what is going on in a problem. Now imagine if you're working in a big company like Airtel. Okay, imagine that you're working in Airtel. Now you're working as an analyst, and you have a regional sales manager or you have regional operations manager coming up to you and asking, how is a performance across the first quarter of 2026? That means from first 3 months of 2026. What is going on? So when that kind of question comes through, the answer is not going to be very big, but very distinct to what is going on. So you have to describe what is going on. That means you will have various charts explaining what is going on, how many customers are using our SIMs, how many customers are using Airtel SIM, what is the number of hours spent on Airtel SIM, how much data are all the customers using in specific region, how many customers are there, how many customers are using what bandwidth of data, because network bandwidths are structured as well. How are they using that? How many people are using that? What is the bit rate? What is the sampling rate? And what is the bandwidth load as well? The band load as well. How much data is being used? What is the cluster of data? What is the cluster of usage? In what specific region and in what specific area are the highest amount of users, lowest amount of users? Everything. Describing the whole problem is what descriptive analysis does. Now think about this. They are not using the past data. They are using the current data. They're using the 3 months data and tell exactly what is going on. And they're not even telling about the future as well. Okay, they're just describing the problem. Now this is where they'll be using past data and present data to describe the problem. So that's what is going to tell them understand what is going on. Moving on to the next one, diagnostics. Why is it happening? So out of that analysis of the Airtel users, now the senior manager asks the analyst that, okay, there's a problem that we are seeing a specific area in a city. Let's take Bangalore as an example, and let's take Indiranagar as an example. The manager sees that specific area in the Bangalore, that is Indiranagar. He sees that there is a drop in usage in Indiranagar across in the second month of the quarter. So in February, they see that there is a drop in the number of users in Indiranagar. Now he wants to know why is it happening. In the descriptive analysis, he sees that there is a drop in Indiranagar. Now he wants to know why is it happening. So he asks the analyst, can you find out why is it happening? Then the analyst go on to find the data and find the answers to why is it happening. So he goes through all the usage data, everything. He goes through. He finds reason behind that. Maybe there is less network connectivity. Maybe there is restriction over network. Maybe there is some issues that are going on with some phones, or there might be some other company, a competitive brand that might be giving them tough competition, like maybe Vodafone, maybe Jio, who is giving them good competition. That means the network there specifically, they might be having 5G or 5G plus as well. That's the reason why people are much more aligned towards Jio or Vodafone than Airtel. Could be the reason. So he tried to figure out why would that be reason, and then he'll come out with a reason that there has been in the month of February there was maintenance work going on in Indiranagar, because as usually Bangalore roads are dug up every day. There was a road work going on, because of which the underlying network cable was broken down, was cut off, because of which the network connectivity was affected. So the number of users in Airtel on the Airtel carrier fell down in the month of February, because there was specific work that was being done on the infrastructure, that is the network cable connecting to the towers as well as to the nearest receiver and broadcasters. So he found out that that's the problem. He shows this to his senior manager. Okay, this was the problem. This is why there was a dip in February. Now moving on to predicting. So then senior manager asks him, okay, this was the reason. Okay, fine. Can you just find out using the previous experience data and present data? Can you find out what would happen in future? Now this is where complexity kicks in. Okay, this is where you were telling that analysts don't do in future one. This is where they do that. He's still analyzing. He's not creating a model. He's not creating some new data model to predict something. No, he's not doing that. He's using some rule-based theory, some rule-based approach to figure out what happened. If this, if not this, they use this certain logics to figure out what would happen in future. Of course, there will be some basic prediction there. That doesn't mean that this prediction is straight away using artificial intelligence. I really strive and I really stress on this topic to all of you guys that please don't use the term AI in broad sense. Don't abuse the word AI and ML. AI is not everywhere. Not everywhere you need AI. You don't need ML everywhere. There are some specific rule-based theories as well that can just give you some predictions. They can give you some predictive information. It not need to be 100% sure, but for some reasons you can just use that. You don't always need to have an AI model. The topics of AI and ML, that's a bit different. That I can tell you a bit differently, but still I'll just convey you what is the difference between a rule-based theory and what is AI ML. See, artificial intelligence is built on models. Now these models are using data from years loads past data and present data to create certain specific predictive models where they give certain objectives to the data to make sure if certain case happens, they'll train the data to make sure this should give you what exactly might happen based on these certain scenarios. So all of these things, all of the examples, all of the previous experiences, they use to train the data and get a data model that can give a prediction of what might happen in future. So predictive in AI, in the world of AI, that's what. But in rule-based system, you need not create a model itself. You can just use the data in the past, provide some logics. For example, if this, if not this, if else, there are some logics there. In computer science, there's a very common things that you have in programming, in object-oriented programs as well. You have the basic common fundamentals of logic creations, where you have the structures of if not, which, for loops, or you can use basic of those things to figure out what can happen and what can happen in future as well. Short-term future. That is what can be done in analysis as well. You need not have AI ML everywhere. So in predictive analysis, that's what can be used to do a bit of first level of predictive analysis. But if there needs a certain model that should regularly monitor these future outcomes, then you might need to have an AI model or a data model that can predict what is happening in the future. And moving on to the next one. So the senior manager gets an understanding. So analyst, he digs up the previous experience, previous past incidents where the data cable was stuck or the infrastructure was affected by all of this basic problems, and the network issues were downtime. So he gets all the information and figures out that during certain times he find out the analysis, he find out the answer to this as well. What will happen in future? That on certain durations in certain time period in a certain year, these kind of roadworks do happen. Now, how will it happen? For example, very clear example, very close to elections, all the politicians try to lay off all the roads, do all the infrastructure work so as to please the crowd. They do that, and very close to this, you will get a lot of problems, obviously, because they are digging up, creating some things as well. So you'll get a lot of these things. So you understand that there was something going on. There was some close to these elections. There will be some of such stuff happening because this happened in the past as well. Now, what does senior manager do is he asked him, okay, so this is what we found out. So can you just find out and give us a solution to this? Can you prescribe what can be done as well? So what he does is he tries to fetch up information from various other different locations and different data pools to figure out what is the best use case scenario, what can be done out of this one. So he finds out various conditions or various situations or various actions that can be taken. For example, before these things are happening, they can send out a warning message to all the Airtel users that there is a certain work that is going on. First thing. Second thing, he provides a solution. He provides analytical solution, that prescriptive solution, that the data from the government body or the council body is used to find out if there are any roadworks or any such infrastructure work are planned in future days, so that they can provide some mitigative actions to the network. So there are these are two solutions that it comes out with. So this is how prescriptive analysis also asks. So what to be done? This is answered here. So using the Airtel's case, I've kind of explained all the different 4 layers of analysis. Now we are not using anywhere AI models here. We are not creating any data models here. And that's the difference between a data scientist and a data analyst. They can still use the present and past data to create something to answer these questions that are there in front of you. These are the types of data. And when we speak about complexity around this as well, as I mentioned, the more you move towards trying to answer some future questions, some questions related to future, the complexity increases, because you have to create some rule-based algorithms to let your data understand a bit and give you some future metrics and understanding, future metrics and solution to that as well. So quite in a very plain language that is there in front of your screen right now. So descriptive analysis that summarizes summarizes or describes the features of a data, such as very basic statistical fundamental concepts like like standard deviations, correlation, covariance, mean, median, mode. These things are already usually used as metrics to measure your descriptive analysis. Then going down forward up, you have diagnostics, where you have an example of why did something happen. For example, website traffic. Why did it happen? During certain time period, the website traffic broke down. Now, why did it happen? Search engine algorithm update 1st of August, 25% decrease in published content, lost a record amount of backlinks. These are the reasons why it happens. So diagnostics, they found out why the reason why it happens. Why did it happen? This is a type of analysis. Then moving on to predictive, you have different ways of doing that. Facial time series model, clustering, sentimental analysis, Elliott wave, correlation analysis, time series model. Not everything is done by data scientists. A part of this is done by data scientists as well. So this is where data analysts and data scientists work together and try to get some answers out of this. So not every time it's just data scientists doing that. Not every time just a data analyst using that. Depends on what type of data and depends on what type of question that they're trying to solve. They'll get this one. They'll try to break it down to the way that they want to design the solution. Then prescriptive. After predictions are done, what are the decisions and what kind of effects that can follow through in the future? So what will happen, when will it happen, why will it happen? This is what predictive analysis tells. How do we benefit from these predictions? How will these decisions impact everything else? This is what something is taken out of descriptive analysis. These are the key difference. Now, if you want to be a data analyst, let's not focus on data scientist. Okay, let's take first step of data analyst. Some key basic things that you will be needing. You can take screenshots of this. You can keep this for just your fundamental understanding. From the first basic things that you need is some basic operations like the data operations that you need. SQL, Python, JSON. JSON scripts are normally used in some of the different softwares where you're trying to make sure you link your analysis to certain softwares, where you're trying to link your data to certain software apps and fetch the data and showcase in a different method as well. They could some web apps for you to join. So not necessarily everybody will be using JSON, but SQL, as an analyst, as a data scientist, SQL is your bread and butter. Without SQL, you cannot do shit. You cannot use anything. You cannot do anything. You have to know SQL. You cannot do anything. So you have to know SQL. You can learn SQL for free everywhere. There is SQL trainings available for free in YouTube, and Vijesha also offers in-person SQL trainings as well. There's a lot of resources that you can find out about SQL, and you can also do some projects as well. So SQL, Python, you can use that. Python is also useful because Python is not just one single tool that can be used to do certain things. Python has libraries. So you can use Python libraries to do anything that you want. You can answer any solution, any question. You can answer anything, any problem out of Python. You can create anything out of Python. So that's why Python is a very easy and very flexible platform to create these things. So you can use Python libraries. There are certain Python libraries like Matplotlib, Plot. There are a lot of libraries in Python, so to use that. Then analytical tools. Okay, let me first come to cloud operations. Cloud operations. Now, they're cloud, cloud tools, AWS, Amazon Web Services. You have Amazon Web Services. They have certain products in cloud as well. Now, in order to use them, you need to know how and what those systems are, what those products are, how do you use them. So you need to get some fundamental trainings or some intermediate trainings as well, depending on what we'll be using, what your company is using. Mostly people are using AWS because AWS is very much advanced. Then you have Snowflake, then you have Google BigQuery. Now, Google BigQuery is a subset of Google Cloud. I should have mentioned it together. But yeah, in Google Cloud itself, you have BigQuery. BigQuery is a platform within Google Cloud where you can query the data, store it in tables, and perform SQL operations to offload the data, use the data to feed back into your analytical tools. Now, coming down to analytical tools, you have these analytic and visualization tools, which are very powerful and very useful. Tableau is a very big package and also very expensive. Very big companies only use this. We use Tableau. We also use Power BI, but Tableau is something very big and very interactive as well. So all of these tools that you can see here, they are very interactive to various softwares and various applications that we might be using. So you have Tableau, you have Power BI. Tableau is a part of Salesforce, but whereas Power BI is a part of Microsoft. So when you purchase a full 365 package of Microsoft Office, you'll be getting Power BI along with that as well. So if you learn that, it'll be very useful for you. Most of the companies use Power BI. Then you have Minitab. Now, Minitab is very, very powerful and very different from all of these ones, because Minitab just is a very powerful tool to visualize statistical data, not every data. Minitab is very powerful in doing the statistical data analysis. For example, control charts. Minitab is straightforward, very easy. You just feed in the data and pick all the parameters that you want, and it will give you very distinct and very detailed analysis of your statistical analysis. So Minitab is useful for that. Then obviously you have Python plots. You can use matplotlib, that is in Python, that is a library in Python you can use to create Python plots. Then you have MS Excel. I tell this to everyone. MS Excel is something that everybody should know straight out of coming from school. If you finished off school, you should know MS Excel. Without MS Excel, you cannot do anything in the whole world. So learn MS Excel. MS Excel is very useful no matter what and where are you doing anything. MS Excel is very useful. Anything in MS Office is very useful. So yeah, MS Excel can do many things. It can do a lot of operations as well. So advanced Excel helps you to create a lot of codes as well. You can create codes in MS Excel to perform certain transformations to your logics, to your data as well. So Excel is very powerful these days, unlike previous days. And these are the bits of technical aspects. Then the communication. Something that differentiates you from a data scientist or an analyst is communication. Because scientists don't give much importance towards communication because their data models will speak for it. But for an analyst, where you're trying to convey your work to a normal human being in a human understandable language, you need to know these bits. You need to know presentations, how to create very interactive and very proper presentations to show your data. You need to learn that. You need to know how to structure your presentations to actually target your target audience. The message that you're trying to convey to your target audience is very crucial for you to design how you're going to structure your presentation. So presentations are key bit when you are actually showcasing your answers. Reports are detailed analysis. Okay, it's not just presentation. Professional reports are very big. It's not like the project reports that you create in your colleges. Professional reports follow very high quality industry standards. You need to have all the indexes. It almost follows the same thing that you do in college, but it is much more developed on that. So you need to have reports very detailed, very properly labeled everything. Your report should be very descriptive, very detailed, self-explanatory, so that people shouldn't question you back again. 3-point approach. Something about 3-point approach is like STAR process, STAR method. A 3-point approach is, firstly, what was the requirement? In your communication, you have to answer these 3 questions when you're presenting. Firstly, what was the requirement? Second, what did you do and how did you do it? Thirdly, what is the future outcome? What needs to be done in the future? So This is a star kind of a star approach is a much more lengthy one, but 3-point approach is something that you have to take in presentation always. What was requirement? What have you done? And what will be done in future? These are 3 things that should always keep in mind whenever you're doing brief presentations. When detailed presentations, you have to do a bit more in there, but these are the fundamentals for your communication. Again, going down to soft skills. Soft skills is very important because if I'm speaking something, instead of telling a specific word, if I tell some different word, people will not get your answers. That's the reason why language is very important. Language understanding, comprehension, punctuation, where to stop, where to continue speaking, where to stress, what words to stress on, how to address people, how to address something. These are very key bits, very fundamental things. People fail doing this. I've seen people, I've worked with certain people who are very good at technicals, who are damn good, really damn good at technicals, but they're really let down in terms of language, in terms of soft skills, which is a very bad thing. Because if you can't communicate your work, if you can't work as a team, if you cannot work as your team and convey your work as a team, it's not going to help you anywhere. Even the people who are seeing your work will not be happy. Explanation. Secondly, explanation is something different. People don't put much stress on. When you're explaining certain things, you have to sort of explaining that you have to start from something and end at certain thing. You should not mix match everything. Okay, you should not start the middle telling that, okay, I was doing this, and then you go back to telling that why was I doing this, and then you straight away come to the solution. Okay, I created this. Then you shouldn't tell that actually the customer also required this one as well. So you again don't go back to requirements. You have to structure explanation so that the listener should not get confused about this. So you have to structure everything on like that. On-spot answering, obviously, rapid fire things. If you know your work, there's a general thumb rule in the whole world. If you know your work, you will have answers. If you don't know your work, you will not have your answers. That means what? If you worked on your problem, if you worked on your work that you're supposed to do, only then you'll be having answers. So make sure when you're working, you put all of your efforts. Don't cheat on these things, because this will let down in your career itself. You'll not be able to learn this. Because for an analyst, the growth profile is very high. So you can pick up these tools very easily. You don't need to have huge experience. You can pick up these things very easily in a very short amount of money as well. You can pick these up very easily and build your skill set. So it's very important for you as an analyst to have these soft skills. Obviously, MS Office should have been technicals, but yeah, it's also a soft skill because you need to know how to use MS Excel, MS Office. You need to know how to use MS Word. You need to know how to use MS PowerPoint, Outlook, Access, Power BI, MS Excel. There's no brainer about this. You have to create reports. You have to create your stories. You have to create your trackers. You have to create your data tables. You have to share your spreadsheets, everything. MS Office is your answer. Even PowerPoint presentations. So no doubt, no brainer. You need to know MS Office. That includes MS Excel. So this is what you need to be a good analyst. Now, moving on to career opportunities. Obviously, right, you're doing this for your career. You need to know what this enables you as well. As a data analytics engineer, firstly, you can create analytical solutions. That means you can find out you can find out the insights from your data and provide this to create a solution. For example, even in engineering world, you use this data to create a solution out of this. So that is what something data analytics engineer does. Then you have business analysts, not just engineer, but business analysts / engineers. So business analysts use the business data to provide information to business related operations, including supply chain, HR, profit loss, financial things, financial aspects, market growth, and market analysts and everything. Then you have research analysts. Research analysts are specific to certain organizations, certain organizations who are doing certain research. So, for example, government organizations normally have research analysts a lot, and some of the companies like press journalism, press field, some of the journalist companies as well, journalist organizations and brands, they use research analysts to do certain research and find out the analysis out of that. You can be a research analyst, obviously. You don't need to have specific knowledge for this. Uh, then you have cloud computing. Obviously, cloud computing agencies also use analysts because they need to analyze their data as well. It's quite complicated to manage cloud data. Autonomous technology, obviously, cars, planes, buses, everything in transport systems, they use data. Nowadays, data is everywhere. So obviously, if data is everywhere, your job will be there as well. No matter what country and what company you might be working with, you will always have solution and jobs there. Mathematical modeling, very good example of COVID predictions. So, IIT Madras was doing this, where they had a data model set up to predict when a new COVID wave could come through, what could be the fatality rate, and what could be the effect of this as well. So that was a part of mathematical modeling. So yeah, you can be working alongside with such organizations as well as a PhD or for a PhD training or a research work as well. Then future predicting ML and AI models also. Yeah. Also, although that data analytics is a step to data science operations, but yeah, you can work alongside them to provide predictive and prescriptive analytical solutions. So this is what's happening in the world. This is what how data analytics is, and this is what how the effect of data is everywhere. And I've given you enough information that can give you a good example, good understanding about what you can use to be a better person and a better analyst as well. You can decide your future on this one. But yeah, ending on this note, I would like to take questions now. It's quite difficult to read through all the questions because I've got so many messages in here, which is very difficult. I'll try to read through and find out if there are any questions before I head on to take your questions as well. Um, just a moment. Shiva Sharana, you have a doubt, you have a question. Are you there? Do you want to ask a question? Shiva, are you there? Okay, fine. If you guys have question, can you please unmute yourself and ask your question, please? Huh? Any questions? Does anybody have any question? Do you want to unmute yourself and ask the question, please? Nikhil says, me, sir, can you explain the types by taking real world problems? I did exactly the Airtel problem that I told you guys.
Hello.
Yes, Prashant?
So I have a doubt. I log in with
Mhm.
2 accounts early.
Sorry, I can't hear you properly.
Sir, hello.
Yeah, go on. Yeah, I can hear now.
I log in with 2 accounts earlier. Okay.
Mm-hmm.
We just removed it because of I texted in chat.
Mm-hmm.
So I can't join with that account, but it registered in your website.
Okay, I don't know about that. See, that's not something that I'm handling. It's
Okay.
the that's the event constructors who are handling that. I'm not handling that. Apologies for that.
Okay, sir. But
I can. Okay. Any questions, guys? Any other questions? So, SSK tells that sir, data analytics is best example for YouTube Studio right now in this generation. Data analytics is everywhere, my dear. It's everywhere. It's not just for YouTube Studio. YouTube Studio uses so many things you can't even imagine. The amount of tools even Netflix uses, you can't even imagine that. There's so many things going on in the background and so many analyses that are happening right now. It's not just YouTube Studio, everywhere. Shrikant Sajjan, what is the work of data analytics engineer? That's what I explained, Shrikant, for all the long. I'll still explain you the same thing. Going back to the definition again, data analytics engineers work is to understand the engineering data or find out solution or find out insights from the related data to give out a solution rather than just giving out insights. Those insights should be able to used as an engineering solution. For example, in automotive itself, we have a current problem right now. Think of it like we are coming up with a new product, not JLR. I'm not speaking about JLR. I'm not speaking about Jaguar Land Rover. I'm just giving a very general answer. If we are coming up with a new product where I want to make sure if I'm working with some car, let's say Safari Dicor. Okay, Tata Safari Dicor. Now Dicor is 7-seater. If I need to know that how many customers are actually using the 7-seater, the third row seat, how many customers are actually using, how many customers are purchasing that. I read through the previous data, the usage data. I read through the purchasing data to find out how much of demand was it there and how much of interest that has been shown, to figure out if in my new product, in my new version of the car, should we be including the third seater or can we just have 5-seater and have some different features there as well. So I'll analyze the whole data and provide a solution to the company that the 7-seater is very much useful in Dicor, but there is some interest in, there are some people who are not using 7-seater. That's the third row seat as well. So that means the company will decide that, okay, this is informative. So what we'll do is we'll keep the Safari Dicor, but we'll also bring in a new product which will be very short in number, but we'll only create this for 5-seater and add some extra features to that. So now this is the solution that the business takes out of the data insights. So this is what a data analytics engineer's work will be, how they can use the data to provide solution. An engineer's job is to provide solution to problem. An analyst's job is to analyze the data and give out the insights out of that. An engineer's job is to provide solution. So a data analytics engineer uses that data to provide a solution to a problem. That's your difference. So Gamer Gent, nice name. Sir, what was the first step to become a skillful person? Persian, okay. Well, you first need to be a good human. You first need to get your English right. You first need to get your communication right. You first need to get your discipline right in order to be a very skillful person. You should not procrastinate things. You should be very diligent with your work. You should know your career. You should know your things, know your stuff. Thumb rule. Know your tools that you learned. Know your domain knowledge that you learned from. That's the most fundamental to be a skillful person. Which industries currently need data analysis? So this is the list that I showed, Meghana. Almost every industry needs, including textile industry, telecom industry, medical industry, government industries, government organizations, military agencies, autonomous vehicles that includes aerospace techniques, space technology as well, space science, research analysts, everywhere. Data is everywhere, so analysts are everywhere. Essay is also sir, we can also tell you, is a demotivate, demotivate for us. This is the main disadvantage, right? Sorry, I don't understand that. Vidya D, sir, what mistakes do beginners usually make while learning data analysis? Wow, very good question, Vidya. Really nice. What mistakes do beginners usually make while learning data analytics? You asked a very, very good and very important question. The most fundamental mistake that everybody does is to learn these ones, to learn these analytical tools. This is the most fundamental mistake that every analyst does. You don't do this. Okay, you first understand this. Obviously, Excel is a tool that everybody needs to know. But in order to be a data analyst, you have to understand these ones. These are very important. You need to know SQL, you need to know Excel operations before you go on to create analytical tools. Because if you don't know your SQL inside out, if you don't know how to clean your data, how to transform your data, how to onboard your data, how to tabulate your data, how to label your data, if you don't know those basic things, then you cannot visualize in your analytical tool sets. So everybody right now, what they do is they try to learn the tool. Don't learn the tool. Learn the knowledge behind that. Learn the artifacts that are used in the background. For example, SQL straight away. It's very important to be an analyst. So first learn that before you go on to do this. So I guess with that I've answered you. Data operations, firstly. Secondly, your soft skills. Thirdly, your cloud operations, and then analytical tools. It's very important. We have to follow this architecture, follow this method of doing that. That's how you can be a good analyst. These are the key mistakes that they do. Srikanth Sarjan, how much salary of data analyst engineer? Good question. So for a starting salary for any data analyst, it starts from 5 LPA. Depends on your experience. So if you're a fresher, it starts from 5 LPA normally in India across different industries. It's on an average. I'm not telling you this just 5 LPA, but on an average starts from 5. But as and when, the more tools you learn, the more technologies you learn, and the more projects you solve, and the more you get. For example, right after 1 or 2 years experience, your salary band will jump straight away to 8 to 10 LPA, and it can include it can increase more as well, depending on what level of complexity you're solving, what level of projects are you solving, depending on company to company again. So the salary starts from 5, and it lasts until 22, 20. Yeah, around 20 LPA as well. Some of the companies do offer 20 LPA. So yeah, the salary band is very huge. What qualification are required to become data analyst? Qualification, good answer. So you don't need to be you don't need to have a specific qualification, but you need to have certifications. You need to have certifications of doing certain things. For example, you need to have a certificate of good SQL skills. You need to have a project experience for that. It's okay even if you have a bachelor's or a good workshop or a diploma as well. Having an MSc in this is a bit more exaggerated. If you're doing research over this, it's good, but you need not do all of those things. You can just have certifications to become a good analyst. Qualification terms, you need to understand the fundamentals of your computers, programmings. You need to understand fundamentals of some IT networks as well. So just fundamentals. You don't need very big out of that. So you don't need to pursue a degree in that. I'd say it is. I believe it's still a marketing gimmick that most of the colleges are coming up with bachelor's degree in AI ML. It is big. Understand AI and ML, but for data analysts, you don't need that. Okay, AI ML is still a development thing coming out of an analyst. So it's a very big thing, obviously, very big domain and subject as well. But I still think that you can do many things using the available tools and resources online itself, rather than doing a full-fledged MSc on that. So yeah, that's all your qualifications. So I guess we are on time. Does anybody have any question? I guess we just have 1 minute. I'll take 1 minute to answer your questions, because right after that we can start the quiz. Azia Free, I see your hand up. Do you have a question? Ankita, Nagraj, Gamer, do you have any questions? Okay, fine. So we are out of time right now. I'll take some questions. I'll add in my LinkedIn link to this as well while you're doing the quiz. You can ask me questions there as well. And yeah, if there are any further questions, you can reach out to Vijesha. They'll be able to direct your questions to me, and I can answer to them as well. So thank you very much for your participation, everyone. I hope I've covered some of the questions, because there are many questions right now still coming up. I'd highly recommend you guys to talk to the team in Vijesha to provide your questions so that I can answer you as well. So yep, thank you. And the certificates, the team in Vijesha will be getting that to you. Don't worry about that. Thank you, everyone. I guess Tasneem, you can take over for the quiz.
Yeah, sure, Ashraf. So thank you so much, Ashraf. It was really a very informative and wonderful webinar. I really hope that students might have gotten to learn a lot of things. So thank you so much.